This is the experiment about the rehabilitation of the potassium-40 isotope within kalium hydroxide. There is a small cup in front of us with Kalium-Hydroxide containing potassium-40, the range of the activity of which is about 0.35, 0.40 microsievert per hour. The temperature of the kalium hydroxide within the cup is 16.7 grade centigrade. There is also 4 other small vessels, small tube-like vessels on the table. 2 of them containing kalium hydroxide with potassium-40 isotope with periodic number 19 and atomic weight 40. The potassium isotope is a process with increased neutron process dominance, reason of the isotope status. The normal atomic weight of the potassium process is 39. There are 2 other pots here with kaolin and with a so-called mixture of Decomix. The Decomix is the elementary mix to treat the kalium hydroxide. I will introduce the elementary composition of the Decomix later during the experiment. Now we mix the spots. This kalium hydroxide we mix with the Decomix. You have to mix it very well. So it now is a kalium hydroxide with Decomix mixed. And here is the other mixture, the kalium hydroxide mixed together with the kaolin. So we have now from the 4 vessels just remaining 2 with kalium hydroxide with Decomix and kalium hydroxide with kaolin. Now let's take a look at the background radiation. The background radiation is 0.17 microsievert per hour, 0.16, 0.17. We leave the mixtures working, and we now have the time to speak about why we use Decomix and kaolin for the experiment. The reason of using kaolin is to demonstrate the difference between weakening just the activity of the kalium hydroxide because the activity works with a higher volume of the kalium of the activity, and the Decomix is the one which is really decontaminate. So kaolin is weakening the activity, certain dilution. The activity of the kalium hydroxide is acting within an increased volume. And Decomix is the one which actually is making the decommissioning, the decontamination. The Decomix is speeding up the rehabilitation of the potassium-40 isotope within the kalium hydroxide as it works out the damage causing the isotope status. Let's see the activity levels of the two mixtures. This is the kalium hydroxide with Decomix, 0.12, 0.13. So this is actually at the level of the environment or the background radiation, and the other is the same. So both affecting as reducing the activity. So what is the difference? The difference is in the temperatures of these two. The temperature of the Decomix is of the Decomix mixture is 19.2 now, and the temperature of the Kaolin is still 14.3. So the Decomix is increasing the temperature of the kalium hydroxide, because the kalium hydroxide is start to lose that balance problem which is causing the isotope status. So the 1.3 billion year self-rehabilitation time of the potassium-40 isotope is working out now with the reaction with the Decomix. Now let's take a look at the temperature. Is now already 21.3 grade centigrade, and kalium hydroxide with the Kaolin is just the same for 15.9 grade centigrade. So this is the reason the potassium-40 isotope with increased neutron process dominance becomes treated, and its 1.3 billion half-life 1.3 billion year half-life becomes reduced to a couple of seconds. The neutron process dominance of the Kalium-40 isotope and the integrated proton process dominance and electron process surplus of the Decomix reestablish the balance status of the potassium process within the KOH, kalium hydroxide. Let's take a look again to the temperatures. Now already is 22.9 here, still 15.9, 16 grade centigrade. This is time now to speak about a little bit about the Decomix itself. It is a certain composition of elementary processes with hydrogen, oxygen, nitrogen, carbon, sulfur, silicon, aluminium, magnesium, phosphorus, iron, and titanium. And the reason of the increase of the temperature is that the energy, which has been in normal circumstances developing slowly, working out the balance damage of the potassium process for 1.3 billion rays, now is generating in a couple of minutes. Let's take a look again at the temperatures. The temperature is 23.8 here in the mixture with Decomix. Let's take a look at the other. Here the temperature is 16 grade centigrade still. So there is a 1-to-1 mix within the Decomix pot. A 1-to-1 mix results in fact immediate reduction of the activity level. Taking the decontamination mix with smaller portions, the rehabilitation would take more time and the heat generation would be also with slower gradient. Let's see the temperature again. Already 24.6. So the temperature is growing and growing. Here the temperature is 15.6, 15.8. We could follow the process step by step for long, but the practice shows that at this external temperature of the environment, the mix with the Decomix would reach around about 15 grade centigrade more than the external temperature. But this take a long time, and then we have to complete our experiment now, taking a look again at the temperatures. 24.6 and 15.4, and taking again a look at the activities. Here 0.12, 0.13 microsievert per hour, and the other 0.13. So as closing the experiment, I would like to underline that the experiment demonstrates if we consider elements as processes, the reason of the isotope status can be formulated more precisely, and the speeding up of the rehabilitation is possible. And